Well, I forgot to record a video intro to this mini project, so I'll just do a bit of a voice overlay. This is the start of the rear battery box project, which is a massive undertaking with the DC to DC converter, the EVTV V2 BMS controller, and the charger, plus low voltage wiring, relays, the charging interface, and it's all got to go in and still have room for all the in and out cables and the Tesla battery modules. So let's get started. Please feed the YouTube algorithm by giving the video a like. If you want to see more like this, click subscribe and ring the bell to be notified of new videos. If you want to chip in on my expenses, I now have Patreon and YouTube memberships. And here's a sneak peek at the first piece of equipment going into the rear battery box. This is the EVTV. They call it the V2, but it's their battery management system for Tesla modules. And it goes in this box. I'll show you the progression as we go along, but it's got two huge contactors that can take 1,000 volts at 1,000 amps. It's ridiculously huge. But I've asked for several modifications because this box is going in here and it's super tight to where the batteries will come to. Basically anything on this face of the box is inaccessible. So we moved the contactor indication LEDs up to here. If it's green, the positive and the negative contactors are engaged. The battery power goes in here. CAN bus, the charge enable signal, and the cooling enable signal come out there. And on this side, we have the DC power going out. We have 12 volt DC input, the Tesla data communications cable that goes to all the modules, a power switch that I will bring remotely and install on the side of the box, and a USB connection, which I will also bring out the side of the box, where I can plug in a laptop and configure the settings for the box through a serial communications system. And so I'm going to give this back to Zeke because today we got it back from the guy who works around the corner, and he's got a giant frickin' laser, and he lasered the lettering onto this box, which looks absolutely fantastic. So I'm gonna let Zeke get back to work. Oh, look what I found on the workbench on a Saturday afternoon. Zeke's working on my box. He's got the gland nuts in. He's got the contactors mounted, starting the power bus bar, and the other gland nuts and the external connectors starting to come together. Next, I thought I would mount the coolant reservoir, and I want to keep it at the level of the top of the box so it doesn't bang into the other side like the charging one did. And that still gives me plenty of room for hoses, and I'll just mark and put riv nuts in, and then it will get bolted in place once the rear box is in its final position. Okay, riv nuts are in, it's bolted in place, and the thing I realize is these bolts are going to be extremely difficult to reach once the box is here. I may have to get them up from underneath, or just leave it bolted in and somehow angle it in and then drop that corner, because this is going to be very hard. And this is the thing you run into all the time in these confined spaces. There's just no room. Next up for mounting is the DC to DC converter, and it's got some heating grill for what little heat it makes, and I want to tuck it right in the corner so I have maximum space here. But the issue is I've got to be able to get a wrench in this corner. so it's going to have to move over a certain amount just so that I can get that in there. Well, since Zevon is so dumb stupid to realize that their heating or their cooling vanes will get in the way of their own mounting holes, I figured something had to give. So they sacrificed a little bit, and now the nut driver goes straight in perfectly. And nobody's going to see it. Oh, and on the back side, I want to show you, this is the charging profile, or the DC to DC profile, sorry. It will produce 30 amps worth of 12 volts, which is probably more than I'm going to need. So we'll just hold on to this one. And there it is, went in smooth as a baby's bottom. And I ground down the bolts on the other side so they would be as flush as possible. Next up is mounting the charger in its initial position. It'll go right there, smack against the wall. And these guys, the Thunderstruck guys, are really smart. They leave room for their mounting holes. Isn't that amazing? And as I designed, this is the AC input for the charger, which comes right from the AC in from the plug. So we can make something nice and short right there. This is DC out. We will have a DC bus bar somewhere here, which will come over to the DC to DC. And then off to the battery pack. So let's get this guy mounted right there. Okay, the charger is bolted in with the lovely bolts with lots of clearance, and the excess bolt material has been ground down on the other side so as to not get in the way of inserting this back in the car. We are cooking with electrons, man. This is fun stuff. Now I'm just waiting for the V2, which will bolt in right here. Okay, we have the major pieces here in the rear box, and the V2 is here. So I took out the charging socket again because it has this red and green LED space, and you can see a tiny hole right there, and you can insert an LED in the back of it to light things up as a charging indicator or an error indicator. Unfortunately, it doesn't supply with the unit LEDs or cables, so I had to make one myself, and you need to put a 1K resistor in series or you'll blow up the LED. And then I made the cable the proper length, but the LED is a little bit too big for the hole, so I need to drill that out. So let's do that now. Okay, I've got the LED set up on a lab power supply, and contact. Well, it lights up. Guess it does the job, but it's not very bright at 12 volts. System usually runs at 13 something. Let's try. It's a little brighter. It'll do for now. I could mess around for hours trying to make that brighter, but I'm not going to do it. Okay, things are really picking up steam. Let's talk about the rear battery box. And this is half of it, which I've shown you before. The front half kind of goes like this, and they screw together once you have the box in the car. In terms of placement, I drew up this physical diagram in CAD. It's not computer-aided design, it's cardboard-aided design. So let's talk about this. The modules themselves take up an enormous amount of space, which is defined by this red line. This is how much the modules poke into this area. And that doesn't give us a lot of wiggle room. I've got this much here, I've got this much here. The V2 box will come here. So there's not a lot to play with. But I do have space down the side and a little bit of space along the front and down the side. So that's why I've looked into doing the penetrations of cables and pipes and things through the bottom. Each one of these circles represents something coming in from the bottom, which is quite easy. Getting things in from the side is going to be difficult, but once the car's on the lift, I can push wires through, I can push cables through, I can push pipes through, and then route them to where they need to go inside here. So let's talk about the physical layout a bit more. So there's our charging socket, which we have happily got installed. There's the charger, and these two will wire together quite nicely. We have the V2 on the back, and we have the DC to DC converter here, and we've got the coolant housing here. So those are the major physical parts. To get in and out, I need battery power. I need the battery plus cable and the battery minus, or that's minus and plus. We'll determine that later, because the terminals of the battery are here. If I can come up and then straight in, up and then straight in, that will solve a lot of my problems. Coming along here, I'll have the plus 12 going to the front, ground and switched plus 12 coming back from the key relay that's in the tank box. I have 3 cables going to the motor controller, the plus, the minus, and the driving interlock. They call it KSI, key switch interlock. I'll have somewhere here, I'll have a bus bar for the 144 volts and 12 volts. And then over here, I have the coolant loop coming in because the plumbing connections are on this side. So the cooling loop will come in here, plug into this one, plug into this one. And then I need to send plus 12 and ground to the radiator fan and the coolant pump, which will be controlled by a relay driven by the V2 box. So that's pretty much the physical layout, roughly. These whole positions will change. Everything else is pretty locked in. Now, let's talk about the electrical side of things. This is my best shot at the complete electrical layout of every component. Let's break it down. This is the V2 box here. It has a lot of ins and outs. It's got battery power in on both the positive and the negative leg with the 2 contactors. It's got control wires. It needs plus 12. And it's also got an on-off switch and a USB connection. I've already installed the on-off switch over here. Right there. This button will turn the V2 controller on and off. And right next to it is the charger's state of charge indicator. And those will be accessible if you're standing here, you're making a charge, and then you can see the indicator will be right here and the push button will be right there. Now also, both the V2 and the USB both have a serial console that you connect a laptop to control it. And those are going to be right here, using the 2 big wires that came back to the 2 rear batteries. I'm putting weatherproof USB connectors in there. They will penetrate here. I'll make some slots for the USBs to stick on the back of that. I will need to send 12 volts out from the DC to DC to the front. That'll be a very heavy wire. There's the motor controller. Here's the charger. It's got a ton of cables, as you can see, but it's pretty much AC in, DC out, and then some control and signaling. We're not going to use the charge enable signal. We're not going to use the 12 volts that it can supply, and we're not going to use its temperature sensors and some other things. The AVC J1772 connector or controller, which is still in a box down under here somewhere, will control the functions of our system talking to the charger. That'll probably mount somewhere here on the side and connect to the pilot and the proximity pins on this. We will be controlling, or there'll be a cooling relay here which will control the power to the pump and the fan. We've got 3 Tesla modules with their power, data, and cooling. There's a box fan in the corner which is going to be on a 12-volt switch to keep this area cool. And that's about it, I think. It's just a matter of physically getting everything in place now and actually committing, bending steel, cutting holes, joining wires. This is really where the exciting stuff happens. Okay, I'm prepping the rear half of the box. I got the 2 riv nuts installed. I got the 2 battery hold down bars bent and shrink wrapped and drilled. I got to prep the fan that goes on here and attaches to that cable right there. And I'm going to give it the hot glue treatment to fill in these holes in the sides, because I don't think I want to reuse them. And then I can actually put this in place and we can really start chugging along. Okay, the front half of the rear box is in place for fitting. Everything's good. The bus bars check out on their dimension, not the bus bars, the hold down bars check out. I've filled in some holes. I've bolted on the fan, which I will wire up from underneath. And so I'm going to take this out, lay a small bead of silicone and nestle that in a bed to keep the vibration down a bit. Then we'll start doing some more installation here and some wiring. Okay, I got the charging port wired up with the AVC controller. I got the AC wired into the charger, and then I started to look at the positioning of the EVTV V2 controller. This is mounted here simply for access to the equipment. It will be bolted on here. But you can see I've got this much space here and this much space here. So given those constraints, and I also need to make a boltable place for the pack most positive and the pack most negative, I'm thinking that I use these posts like this because I can't make the bend out here. This then becomes a very short run from the contactor to this post and the contactor to that post. And then wires would come in here and bolt on with a right angle lug and just bolt straight in this way instead of trying to make a bend. This one needs to make a bend, but it's a little more forgiving because it goes over here and it won't be too bad there. Compromises. Welcome to Saturday morning after a very long week of building this. I started on Monday with the wiring and I finished on Friday night, including American Thanksgiving days, Thursday and Friday. I had a bit of a short day, but I was here working on this. Now the wire management is not complete with zip ties and things yet because I need to actually power this thing up and see what happens and fix any issues. This is the wiring diagram, and I've made several revisions to it as time goes by, as I figure out how things work and how they really need to be hooked up. So let's put 12 volts on here and see what happens. And of course I forgot that the V2 is on a switch right here. 12 volts, we have a light. No smoke, no fire, no flames. Let me plug in my laptop right here and see if we can get to the software console in the V2. Okay, the V2 is powered up, but when I connect my laptop, it's looping and crashing through the ESP32 boot sequence. So I think I'll have to get Ziki to check the version of the firmware in there. Maybe give it a flash. Now let's see if we can get any life out of the charger. Okay, good news. The charger is apparently powered up. This weird little EVCC box is giving me some flashing, and I connected the serial port and I'm in their console. I don't know what to do in here yet, and I don't have anything configured. I have not built the charging handle that plugs into here, so I can't test any of the charging stuff, but at least that electrically powers up and seems happy. This one needs some new firmware, but all the 12-volt stuff is looking okay. So the next step is to install this in the back of the car. And finally, the box is in and bolted together. I had to put it in, take it out, trim some stuff off, put it back in again. That was a struggle. I mean, this thing fits in by millimeters. Credit to Electro Auto for making a box that takes up absolutely every inch of available space, but it's unwieldy. But it's in now. Next thing is to start planning where the high voltage battery pack cables go. The terminals will all be on this side. They've got to come in and out of the V2 box, hitting the most negative and most positive terminals, so I got to really think about how I'm going to lay that out. And the two wires coming up from underneath, where they will penetrate, where they attach, where they flow, the whole thing. Just before we wrap up, I want to thank my Patreons, Peter Bouvier and Puppy, for their support. We also just popped over 2,000 subscribers, which is quite a nice milestone for my little channel. All support is greatly appreciated. Hey, I hope you enjoyed the video, and if so, please give it a thumbs up. I see that 81% of the viewers aren't subscribed. Please do, as it does help the YouTube algorithm. Take care and see you next time.